Good morning, good evening, good afternoon, wherever you are. My name is Vishnudat, and today we are going to talk about a course which is absolutely crucial for everybody, right? Crucial for especially for the network engineers, and that is WireShark from scratch. So here is the agenda. Agenda is really simple. We are going to talk about why behind WireShark, and we will see what exactly is on Wire. Then I'm going to share a real life experience of Mr. Rahul and Anjali. Who is Mr. Rahul and Anjali? Right? We will be talking about it. Don't worry. Then we will be talking about packet structure in detail, because this is really important to understand the structure of a packet if you want to understand any new technology, irrespective of the fact whether you are seeing a VXLAN packet. Believe me, the basics, the foundations is going to be same for any, maybe for SSL packet, for IPsec packet, for VXLAN packet. It is going to be same. So we will be spending around 20 minutes of time in just discussing this thing. Once we are done, we will be seeing that structure exactly in the WireShark. Then we'll be talking about why deep understanding of WireShark is so important, right? At last, we will be breaking down the WireShark, and we will be talking about the course prerequisite expectations and the next classes, right? So this is the agenda. I promise that if you spend next 45 minutes to 1 hour with me, believe me, there are some concepts which are going to be with you forever, right? This is the first free class of this course. Believe me, the course will start from the next week. So let's see what we have right now. So first thing first, what is on the wire? So believe me, one thing that network engineers like us really like debugging, really like troubleshooting, right? And around 1980s, we have this model which is known as TCP/IP, right? It means that computers were able to talk to each other at that moment of time, right? Suppose we have a computer A, we have computer B here, which is connected to this switch. And if I send a packet from A to B, there is no doubt about it that over the TCP/IP, these computers can communicate with each other, right? But you must be thinking, Mr. Vishnu, why did you put this switch if you have only two computers? See, I am just showcasing you two computers. Maybe there are other computers are on this network, right? So leave that portion. The important piece is that if computer A sends something towards computer B, there is something which is going over this wire, this Ethernet wire. And we all know that the packets which are on these wires are, sorry, not the packet. Basically, ones and zeros are going onto this wire, will be reaching to the switch, and then switch will be sending it towards a computer B if those ones and zeros are for computer B. Suppose there is a problem, and this is a problem around 1980s. Computer is saying that I am sending a packet towards B, right? Switch is saying that I receive the packets from A and I am sending it towards B, right? But the B is saying, but the B doesn't receive any packet. So what is going on, right? This is a really important problem. We need to understand what exactly is going on this wire. Can we do something so that we can tap into this wire and see what are the ones and zeros are going on? And if we can see ones and zeros only, this is not going to create any logic, because ones and zeros are the raw bits. If we can see them also, there is not going to be any use of them. For example, when these ones and zeros reach to this PC, the network interface card is going to receive it. It is going to send it towards the operating system where TCP/IP model is implemented, and layer by layer, this packet is read, right? It's going to be read. You all understand that. But if I really want to understand that what exactly is received on this NIC, we need some software who can present this 1-0 into the packet format so that we can understand. And this was the problem around 1980s, that how we can see what is going over these network wire, Ethernet wire. So in 1987, there was a guy who developed this thing, right? The name was TCP dump. TCP dump was a software which can capture these ones and zeros, and which has the ability to showcase you in the text form that what exactly the packet structure is. But this TCP dump was quite a tool which is kind of command line based, which is text based, no UI was there, right? But there was a network engineer who was facing some problem, and he thought, let's build a tool which can showcase what is going on over this wire in a specific format, in a TCP IP format, you can say, layer by layer, layer 2, layer 3, layer 4, what is happening at what, right? So in 1998, the guy name was Gerald Combs, network engineer like us, very brilliant network engineer, and he developed this tool, right? Because he was going through this pain that how I can see the packets on wire. So he named this tool or the software as Ethereal, right? And this was a magical tool. This was a magical software. Everybody was so interested in it after it. And in around 2006, he renamed it. He put lots and lots of feature on top of it. And he said that this tool is WireShark. So from TCP dump was a totally different software, totally text based, no UI. And then we have Ethereal, and then we have WireShark. Ethereal and WireShark were built by this Gerald. And you must be thinking, Mr. Vishnu, why are you teaching us history? See, these things are important because these things are going to let you know that why basically we need the WireShark. Because around 1980s, 1990s, we had a feeling, we had that need of seeing what is exactly happening over these wires, right? So having said that, now let's see, means there are many problems can happen over a network, right? So we have our two characters, Anjali and Rahul, who are dealing with a specific problem, right? So right now, if you can see here, we have a office particular floor, and there are approximately 250 people sit here, right? Maybe 300 people sit here. And Anjali and Rahul both are network administrator of this company, right? They are networking expert. And Anjali is discussing a particular problem with Mr. Rahul, and Anjali is saying, Rahul, I am facing a huge problem. I don't know what happens, but around 4 p.m. I get around 4 to 5 p.m. between 4 to 5 p.m. I got lots and lots of tickets, and the user at this floor or a particular network are saying that they are not able to reach to internet. Means some can reach to internet, right? But their speed is so slow, and this is happening around 4 p.m. between 4 to 5 p.m. right? And exactly after 5 p.m. when I checked, everything was working fine. So I thought that it might be a glitch in the network. But believe me, Rahul, today the same problem happened at the same time at 4 p.m. People are saying they are not able to access the internet. Even when I connected at the same network, I saw the same problem. And I do not know what is happening behind the scene, right? Then Rahul is listening this situation quite patiently, and he is asking that, Anjali, what is the difference, right? Did you connect something into this network? So by the way, if you are not aware, means whatever you are seeing on this left hand side, the beautiful picture, if you see this beautiful picture from the network engineer's perspective, what you are going to see? You are going to see switches and routers. So if you are not from the background of networking, purely routing and switching, that is perfectly fine. But from networking perspective, this floor will be having some switches, where the switches or the pair of switches or maybe the multiple switches where the user finally get connected with their laptop, right? Or maybe some IoT devices, printers. Those are known as access switches because we are using these switches to access the network, right? And then because this is not a huge network, we have combined two layers, distribution and core, right into the one. So we have this distribution and core layer, we have this access switches, right? And there is one network right here around 250 people which is facing an issue. Maybe some of the branches of or some of the users of this network are here on this switch or on this switch, and we all know that we call them VLAN. If you are not sure about VLAN, that is perfectly fine, right? Now Anjali is saying that this is happening from last 2 days. Today, I got lots and lots of ticket, and Anjali is saying that they haven't connected. Means she's not sure that whether they have connected anything new on this network or not. So Rahul is saying that if that is the case, let's directly go inside this switch and check. Anjali was not aware of the fact that how we can see that, right? Means we can run some command, we can see some packet drops, but can we see the packets also? And Rahul is saying absolutely, right? So Rahul has connected his laptop to this distribution switch. He did some command so that all the traffic of the switch will be redirected or will be pushed to this interface, and Rahul is running WireShark here. Within 5 seconds, Rahul is saying that yes, I see some unusual activity going on. And Anjali is asking, what is the meaning of unusual activity, Rahul? I can see there are so many address resolution packet, Anjali, right? Means I can see that within 1 second there are more than 500 address resolution broadcast messages was generated by a single host, and the MAC address of this host is this much. And Anjali was just amazed. How do you know all these things, right? And Rahul is saying, because I know WireShark. It's interesting and a very, very good, interesting and very, very important software for any network engineer. So Rahul is saying this is the MAC address. Anjali checked the list of the MAC address and she came to know that this is a printer, right? And when she isolated that printer from the network, everything goes fine. The next day, right? Now the question is what this printer was doing. So this printer was from some manufacturer, right? And exactly around 4 p.m. this printer was checked for the software updates, right? And it tried to contact its server on the internet, right? And for that, for the first message, he is doing an R. And if it doesn't find, or if there is some problem in this printer, because of which means we do not know what is the problem, maybe the bug, maybe something. But exactly at the 4 p.m. when it tries to make a connection with its server, right? It sends lots and lots of ARP messages. And those messages were around 1 second, means 500 messages in 1 second, absolutely abnormal. And because of that, every other system in the same network has to process those ARP messages, right? Right? Amazing, right? If you do not understand the meaning of broadcast, believe me, I have created so many videos which are freely available on internet, right? Specifically my interview preparation series, if you can see that, you will be carrying a lots and lots of input regarding how switching works, how routing works, how traceroute work, and so on, right? So by the way, Rahul just asked that, Anjali, what is the problem is this is the time for people to go back to home, 4 p.m., right? Were they logging complaints to you at that time? And Anjali was saying, Rahul, try to understand. 4 p.m. people try to leave to their home, but before going to their home, they maybe just go and check the LinkedIn website maybe for a new job. Maybe they are on the Facebook, they are on the Instagram, and so many things, right? They do this at exactly 4 p.m. to 5 p.m. And we have just created some problem in their internet connectivity, right? Because of this printer. Overall motive of telling you this story is that if you know this WireShark, believe me, it is going to be very, very important tool for debugging. You can ask Mr. Vishnu, how can Rahul get all the packets of this switch, right? Do we have some specific configuration command for that? Yes, there are few things which we can configure on the switch to get the traffic of a particular VLAN, which we known as switch port analyzer, right? Although in some of the switches, new switches, some of the switches, there are many software, there are the things where you can capture packet right on the switch. You can create a capture file and you can open it on the WireShark. Believe me, in some of the Nexus switches implementation, WireShark is right there inside the switch itself. Okay, so now I think till at this board you understand. Yes, means if we get the knowledge of WireShark, if we get the knowledge of packet structure, it is going to be really, really interesting, right? It is going to be really, really useful for us also. So overall, what is happening now to understand WireShark? First thing first, you need to understand the structure of a packet. And I would like to explain you this in some informal way, right here. With real life analogy. So suppose we have two characters, our favorite characters we have Miss Anjali here, right? And we have Mr. Rahul here. They are quite far apart. Suppose, right? So Anjali tried to write a letter to Rahul, right? And of course, we have a postal office service here. Believe me, this is very simple example, but whenever I try to explain the same thing with protocol, with TCP/IP model, people say it's hard. It is exactly the same thing. I will compare step by step. So what is happening here? First thing first, if Anjali has to write, Anjali want to send a message to Rahul, Anjali has to write a letter. So what she does? She has a page, and then she started writing her whatever the message is, right? This is actually the letter written by Anjali. But this letter doesn't have the capability to go on its own to reach Mr. Rahul, and that's what Anjali is going to do is Anjali will be taking an envelope and put this letter inside this envelope and then write the address of Mr. Rahul, and then it delivers this to postal office service. How to deliver, I think you all know, right? If you don't know, that's perfectly fine. But suppose this letter reaches to postal office service. Postal office service is not interested in this letter at all. It is only interested in what is written on this envelope, so that they can send it towards Mr. Rahul. After reading this address has some specific structure which this postal office guys understand, and then they are going to send it towards Mr. Rahul. This is how a normal letter goes from one place to other place between two human beings using the postal office service, right? Very simple. And by the way, this process of putting this letter inside this envelope is known as encapsulation, right? I think you all heard about it. Now let's consider an example. Instead of Anjali, now we have Anjali's computer right here, A, and instead of Rahul, we have computer B here, right? Simple. And now we want to send a ping message from A to B. What is the ping? Ping is used to check whether the other host is alive or not, right? But what exactly happens behind the scene? We are presuming that we are using TCP/IP. Any computer who is talking on internet in today's world, it is using TCP/IP, right? And we all know the TCP/IP layer has some, a model has some layers. What are the different layers? Physical layer we have data link layer, then network, then transport, and then application layer, right? So what exactly happens when you write ping B or ping IP address of B, right? It means that the host A or computer A will generate that letter. You all know about it, right? But who exactly is going to generate that letter? And then you must be thinking, Mr. Vishnu, A, this is what you said. Computer is going to generate that message. But which part of computer, which layer of computer we are talking about, right? So believe me, this ping, right? This ping is part of a protocol which is known as ICMP, Internet Control Message Protocol, which is implemented or which is right there on the network layer, ICMP, right? So just like Anjali was creating the letter for Rahul, if she wants to send a message, if A wants to send a message, specifically this ping message, who will create the message? Who will create the letter? It is the responsibility of ICMP protocol to create this letter. It is going to say, ICMP is going to say, I am generating a letter. The letter name is echo request message, right? And then it is going to put some data here. As simple as that. But as in real life, this letter cannot go on its own. So what we have to use, what computer A is going to do, what TCP/IP model of computer A is going to do, it will take the help of network layer. See, ICMP is the one who has generated this message, right? To whom? To ICMP process or ICMP protocol of computer B. Maybe we can say this is ICMP of A, this is ICMP of B. We have written a message from ICMP of A to ICMP of B. This is the letter, and if I want to send it, we absolutely need to use the network layer, right? So this packet is going to be encapsulated by network layer, and then we have to write some address, just like what exactly Anjali did. But here, instead of Anjali, we have ICMP is the one who have created the protocol, created this letter, and network layer is the one whose responsibility to send this message, right? By putting some address on it. And what address we are talking about? We are talking about IP address here. As simple as that, right? So we are going to put source IP and destination IP, and of course there are other fields in the IP header which we like. So this process is known as encapsulation. We are taking the letter, we are just putting it inside the IP header or IP envelope. But is it enough to send the message? No. After network layer duty is to give this message to data link layer, as simple as that. And at this point now, what is going to happen? Data link layer will take this envelope, it is going to put one more envelope on top of it, and now it will write its own header, means source MAC, destination MAC, and we are calling it an L2 header. Previously the envelope known as IP envelope, right, or IP header. And then basically this is delivered to physical layer. The physical layer, ones and zeros, this message is going on, right? I think we know about, we are not going deep into the physical layer, that's fine. So this is exactly what happens. So you all know that you can ask me simple question, Mr. Vishnu, why there are two envelopes here? Why can't we have only one address? Why do we need to use two addresses? So believe me, I have discussed this in 1 hour. Very, very important lecture. A very, very important discussion point. Why do we need MAC address if we already have IP address? Just try to think about it. Why would I take 1 hour to explain it? Because the answer lies in history. One of the most interesting video. Mostly when I ask this question, why do we need MAC address if we have IP address, people say one is physical, one is logical, that's why I use. No, this is not the answer. Just try to go on the YouTube and try to see why do we need MAC address. Just write my name, you will get the 1 hour explanation. Really interesting, right? Now, do we always need these two envelopes? Can this envelope be more? Let's try to understand. If we take an example of data link layer or the address resolution protocol message R, that message is implemented, or that protocol is implemented at data link layer, right? If that is the case, then if we send an ARP request message, who is going to generate that? Anjali? No, it is going to generate by ARP protocol. So ARP protocol, first thing first, will generate this ARP message, right? And ARP message is going to have inside this what? In its letter, it is going to say sender MAC, sender IP, target MAC, target IP, and so on. But this ARP message cannot go on its own. It needs to take the help of layers, right? Is it going to take the help of network layer? No, right? Because it is implemented at layer 2. ICMP is implemented at layer 3. We do not need IP address to send this ARP message. Why? If you want to understand, just try to see my videos on ARP, right? But our protocol is implemented at data link layer, so it is going to give this to data link layer. Data link layer will encapsulate this message into its header, and it is going to write source MAC and destination MAC. Try to understand, here we need only one encapsulation, here we need two encapsulation. Very, very interesting. It is absolutely necessary to understand who is creating the message and where that message is on, where this message is with respect to TCP IP layer, right? I'll give you another example because this is so crucial to understand. Suppose here, now we have two computers, right? And now this computer, which is right here, wants to talk to internet. Suppose this switch is connected to maybe internet, maybe a router is here, maybe the internet, and then we have this server here. This server belongs to a bank server, maybe HDFC Bank, one of the great bank, or one of the biggest bank in India, right? And computer A wants to communicate to HDFC Bank, right? Over the protocol which is known as HTTP. And you must be thinking, Mr. Vishnu, no, it should be HTTPS. I understand. That's fine. Because now most of the communication happen over the secure socket layers. But let's try to understand. If A wants to communicate to HDFC Bank, right? First thing first, it should write a letter and should say that Mr. HDFC Bank, I want your homepage. When you receive this message, give me your homepage. But this is the letter, right? And this letter should reach to a server, first thing first, so that server can reply. Who has written this letter? HTTP protocol, right? And where this HTTP protocol lies in this TCP IP stack or TCP IP software. This HTTP protocol is now at application layer, guys. Interesting, right? So letter is created, means if I consider this is my letter, it is created by HTTP protocol and it is saying give me your home page. Fantastic. Now what is going to happen? This will be delivered to transport layer. And believe me, at transport layer there are two protocols, TCP and UDP. And most of the network guy try to be at these layer, data link layer, network layer. Nobody take the responsibility of transport layer, right? But it is absolutely crucial to understand transport layer also. It is going to give you the big picture of this complete model. And most importantly, TCP IP is asked in every networking interview. And you say, no, I know network well, I know routing well, I know switching well. Why are you asking TCP IP? But people, if you really have the understanding of networking, then transport, specifically the TCP layer, should be in your pocket, right? So this thing is written by HTTP protocol at application layer. This will be given to transport layer, and transport layer is going to encapsulate this, right? Or put this letter into the envelope and write the port numbers here. Source port, destination port. And this will be your layer 4 header or TCP header. Then transport layer will give it to the network layer. It means that another encapsulation happened here. It is going to put source IP, destination IP, right? And then the packet will go toward data link layer, and then basically we are here, another packet encapsulation, and we are going to have what? Source MAC and destination MAC. So simple, right? This structure is important to understand. If you get this, I will showcase you exactly the same thing on WireShark, layer by layer. This is the letter, this is the data actually, which is encapsulated in TCP. TCP is encapsulated in IP. IP is encapsulated in layer 2. So most of the time you see this structure as this, right? Means first HTTP data, and then this HTTP data is going to have TCP header. This is just like carrying this data and putting it inside the TCP envelope, right? Then basically TCP data is going to be over IP, means encapsulation done by IP by putting the source IP and destination IP, and then L2 header or Ethernet, right? This is the packet we actually see, right? But these two concepts are same. If you get on the left hand side or the right hand side, if you merge them in your mind, believe me, understanding WireShark packets are going to be so easy. As I mentioned, TCP is so important from interview point of view, from your overall network learning point of view. So what I'm going to do is, with this course, because if you want to understand WireShark, if you want to understand TCP IP handshakes or something, you need to have the knowledge of TCP IP first, right? So what I'm going to do is I am going to give this TCP course absolutely free with this WireShark course. Okay, so yesterday somebody was asking on WhatsApp and he was suggesting that nothing is free. Believe me, TCP is going to be absolutely free with this course. Right? We'll be discussing about the various classes in the upcoming things. Right? Do not worry about it. But right now, if I showcase you, this is this is how the packet structure look like. So now let's see this packet structure here, right? The same packet structure. So what is going on here is we have a computer, and this computer is suppose the IP address of this computer is 192.168.12.1, and it is sending a message towards B, right? And this guy's IP address is 4.4.4.4, and it is initiating a ping message towards it. And you all know A has to write a ping message or ICMP echo message, and that is going to be the letter. But if you are seeing this over a WireShark, so I have taken a capture, I have taken this screenshot. Do not worry, I will be showcasing you these packets one by one just now. Don't worry about it, right? But now if you can see that here is the letter ICMP. It is specifically saying this is type 8 echo ping request. It is a request message, right? It is as good as Anjali just has written the letter. This letter doesn't have the capability to go on its own and reach to B. No, absolutely not, right? And what is the data? Data is right here. Maybe A, B, C, D, and this is the echo message, right? This has to be encapsulated by whom? IP, because ICMP work at network layer, and that is what exactly you see. This is the this is the IP protocol or IP header on top of what? On top of your letter. Encapsulation is going on, right? And then basically it is going to be encapsulated again on the Ethernet side. What is the meaning of this frame? We will be talking about in this course. Do not worry about this, right? So if you really want to understand, you need to see the packet from bottom to top in WireShark, because this is how we learned it, right? First there is a letter, then there are encapsulations. How I came across this superb diagram? The WireShark has this capability of packet diagrams also. Very, very easy. Do not worry. When we talk about profiles, when we talk about filters, I'll let you know how basically you are going to get this structure or going to get this view. But overall, the whole sole point here is that if you understand the structure of the packet, it is going to be very, very easy for you, right? Now, what I can do is I can open WireShark for you to showcase you, right? I can open the WireShark for you, right? Let me open it. Let me put it right here. This is my WireShark. Here is my WireShark. Okay, so here you go. So right now you can see that if I open, this is my WireShark. If I open this Ethernet 0, it will start capturing all the packets, and within no time there are going to be so many packets, right? And this is one of the most interesting problem with every network engineer sees, that whenever they see the WireShark, there are lots and many packets are there, right? How we can find a particular packet in which we are interested, and believe me, this is what I'm going to talk about in upcoming 5 more classes of this course, right? So I have a specific ICMP file which I would like to open, right? So before that, let me stop this capture. Okay, and then let me open my file. Open the file WireShark. Okay, and then let me open the ICMP. By the way, on my website, all these WireShark files are there. I will let you know how to go and download these files at the end of this class. Do not worry about it. So if I see ICMP or maybe the ping, right here is the ping. Let me open this ping. I'll say continue without saving, and let me put a filter here, and the filter is say ICMP, so we can see the ICMP message right here. Interesting, right? This is the message, and we can see here this is the ICMP, Internet Control Message Protocol, right? And then we have this data, simple data, and this is encapsulated in the Internet Protocol version 4. You can see it right here, and then this is encapsulated in Ethernet. Do not worry, we will go on various packets on the WireShark, understand its structure, like VXLAN packet, like SD-WAN packet, or maybe ARP, OSPF, or maybe IPv6, whatever you say, right? And that is going to be the agenda. And even if this course finish, and if I came across any specific type of a packet, for example, if I am explaining some, if I get across a .1x packet or maybe anything, right, I can create a video and upload into this course only. So overall, it is really interesting to see the encapsulation process. So if you go from bottom to top, this is right now, which is the letter, right? And then it is encapsulated in Internet Protocol version 4, then Ethernet 2, or IP, then basically MAC, or maybe the layer 2, right? If I let me open another thing for you. Let me open a interesting. Let's go back again. So we have this WireShark files. And then let me open TCP packet for you, suppose, right? And let me open this data transmission. Let me remove this filter. So, and you can see this is my application data. So you can see that now this TLS, the transport layer security protocol, which layer it at? This is at application layer. So the data is written by transport layer security. It is encrypted data, right? So this is the encrypted data, which is at transport layer security. And then application layer will give it to the transmission control protocol. And that is what we see. The first encapsulation means TLS data, or the letter written by this TLS is right there inside the transmission control protocol. And then transmission control protocol data will be inside internet, right? Internet is going to put the header, and then we have Ethernet, then we have this frame. Do not worry, guys. We will see this step by step in upcoming classes. Having said that, let's move back to my board again. Okay. And let's see what we have on the next board. So next board is why deep understanding of packet is important. So if you see this board, this is just nothing, but what I have done here is I have a diagram of a typical campus network. We have 3 buildings in a particular campus. Now, if you want to understand the how to design a campus network, again, this course is right there in my website. I'll showcase you at the end of this class, right? So we have this network here, access and distribution, and most of the time a network engineer problem is what exactly going on, what exactly is happening in my network, right? So one thing is that with the help of the WireShark, you can understand the network condition, right? What traffic flows are going over over my network, right? And this can be done easily with the help of WireShark. Means you just take this take the output, or maybe take the traffic from this core or distribution, and then basically you can analyze it over the WireShark, right? So for the network engineer, understanding of WireShark is so crucial. If we talk about network security engineers, job is to see what exactly it is receiving at the firewall from outside, right? This is not the only job, but to create some interesting rules, you need to understand the nature of the traffic which you are receiving from outside, the nature of the attacks you are receiving from the outside or maybe the inside, right? And how you are going to analyze the packet until and unless you understand WireShark properly. until and unless you understand the structure of a packet properly, right? So it is absolutely very important for a network security engineer or network engineer to understand the WireShark. The third thing is, it is, if you want to learn any protocol, if you're a student, right, or if you are a network engineer, you want to learn new protocol like VXLAN, believe me, understanding of WireShark is so important, right? Because you can see the packet in actual right there, right? So if you see, suppose we have two routers, router number one, router number two, and we are running an OSPF protocol between them. We know that hello message is going on between them so that the neighborship can come up, and we teach this in theory. But if somebody says, I really want to see that, what is going to happen? You just enable a WireShark. By the way, if you have EVNG lab, you can just create this topology and you can record the messages in WireShark. WireShark is right there, the EVNG, right? And once you see the packet, you can see actually this hello message is created by OSPF protocol. And where exactly the OSPF protocol is? OSPF protocol is at network layer. So OSPF protocol will be taking the help of network layer. It means that this hello message is going to be encapsulated in another message, IP message, and you will be having source address and destination multicast address, and then you will be moving it towards the data link layer. So that data link layer has another encapsulation. Believe me, any protocol, if you want to learn from scratch, understanding of WireShark, if you see the packet with your eyes, what is actually going on wire, if you want to see the BGP update, if you want to see the OSPF update, right, anything, you have to have the understanding of WireShark, right? So for network engineer, for students, for learners, for network security engineers, deep understanding of this packet is so important. One more thing which I would like to discuss is that in a particular campus network, we have lots and lots of IoT devices also. Like we have monitors, we have coffee machines also, we have printer, and this printer was causing problem, right? You do not know that how come these manufacturers have implemented the networking, right? So whenever you install or whenever you get a machine into your network, you want to understand what are the packet it is sending, right? Because you do not know much about IoT devices. So it is always advisable to connect into a switch layer, and then basically you see that what type of packet it is sending. Because for example, during the printer example, right, or the printer experience which we had, if we had known that this printer tried to go to its servers for some updates, and this is the buggy thing, right? The things would have been easy. So to test IoT devices also, you need the WireShark. Overall, I just want to say WireShark is an important tool for any network engineer to understand the packet structure, right? And in this course, we are actually doing two things. We will be talking about WireShark filters, the profiles, and how to go into a particular flow. For example, when we get lots and lots of message, our interesting message is going to lost, right? How to get into this packet, how to use the filters appropriately. We will be talking about it, right? So the next thing is what exactly I am going to cover in this course. So if I break down WireShark fundamentals, so generally what I do, any complex problem, just divide into multiple portions, just read the individual portion and then combine. This is what we are going to do. So if I break down WireShark fundamentals, it is going to give me these three things, 1, 2, and 3. First thing first, we will try to understand the WireShark UI, and we will try to understand how to capture the traffic, what is the meaning of promiscuous mode, and so many things are there, right, which we will be understanding. Then we will be talking about WireShark filters and various personalization, right? That there are display filters, there are capture, so many things are there we will be talking about. And then along with that, we will be taking example and we will dissect various packets. These packets could be SSL, VXLAN, GRE, and maybe IPv6 or whatever you say, right? So I have created a repository of all these packets over my website. If you want, just have a look at it. At the end of this session, I will be showcasing you that what exactly those messages or those capture file look like. So over the period of next 5 classes, we will be covering these concepts, right? So what you are going to get along with this course, as I already announced, that you will be getting transmission control protocol, the complete course of 12 hours along with this course, right? And this is one of the best course I have created. Many people have passed interview just because of it, and now we are going to enhance our knowledge, enhance our WireShark knowledge also, right? If we understand TCP well, because if I am explaining you TCP handshake or duplicate message, if you do not know what these are, why these messages are, what is the purpose, right? So spend some time in this TCP because it is going to be free. Now the cost of this course is going to be, the cost will be 1600 rupees, right? Very nominal price. But for this group right now, I can see there are more than 250 people sitting in this message in this meeting, and more than 250 are, I don't know where are they, maybe the time is not matched for them, right? Or Saturday morning they are not, they were not able to come, so they would like to see the recording. So what I'm saying is, right now the price for this course is 1600, but for this group we have a special discount for you, as I mentioned, that this is going to be in a price of a pizza. So if you book, if you do it today, right, or maybe tomorrow, if you do it, then you will be getting it at 50% discount, means only rupees 800 if you do it today or tomorrow, right? Interesting, right? And then one more thing which is absolutely means it is going to interest you a lot. See, this is the 0th class, or the beginning class, you can say, the free class. There are going to be 5 class. At the end of the 5th class, if you say, Mr. Vishnu, I don't think this course has provided value to me, I don't think, means my expectations were different, right? Can you please give my money back? Without any question asked, I will be returning your money back, rupees 800, right? But I will ask one thing, means that how can I improve, means what were you expecting? So these 3 things are going to be with you guys. TCP course is free. Today, if you do, it's a 50% discount. And at the end of the 5th day also, the 5th class also of this course, if you say, no, I do not like this course, I'll give you money back. Along with that, one more thing, that this course is available in Hindi as well as English, right? Hindi is my primary language, so we have more fun there, but it doesn't mean that we do not have fun in English language. Believe me, both are going to be same, but yes, Hindi is my primary language. So, and if you register this course, see, we do not charge on the basis of language. Doesn't matter if you want to join Hindi or English, or maybe if you want to join both of them, the price is going to be same. So means in 800 rupees, you are going to get the TCP for 1 year. The course value is 3999 right now, if you can see, for 1 year, right? You will be getting absolutely free of cost. Then 50% discount. Then this course is in Hindi, in English, and at the end of the 5th class, if you do not like it, believe me, you can have your money back. So I would say, if you do it today or tomorrow, maybe, you have nothing to lose at this point. Okay, if I were you, I would have done this. And thank you so much. Basically, I can see that there are many. I mean, by this time on your WhatsApp group, there is a link. You can use that link to avail the 50% discount. And I could able to see on my other screen that many people, almost more than 45 people, have already registered, right? Whoever is sitting. So thank you so much, guys, for this. Now the course prerequisite. What is the prerequisite and expectations? What should be your expectations? So if I tell you that only one prerequisite is there for the course, you should be curious enough, right? If you do not know anything on computer networking, also just see my free videos available on YouTube, specifically the interview preparation series, which we have. It is not the IPS, right? It is interview preparation series, which I have created, right? and there are 7 questions. For example, the trace route I have explained in 1.5 hours. What is there to, because I was explaining why behind many concepts. Why do we need MAC address if we have IP address? If you just go through it, your network foundations are going to be good, right? And if you understand Hindi, just have a look at my Be Job Ready course and you should be good. So just need your curiosity. That is it. And then if I do not say I will make you expert in WireShark. So if your journey of WireShark is 100 kilometers, I can run or I can walk with you for starting 10 kilometers, right? But these steps are going to be solid so that you can complete your remaining journey of 90 kilometers with your head high, right? So overall, there is no prerequisite, but yes, it would be great if you understand the foundations of computer networking, like little bit of switching, little bit of routing, right? So now what I would like to do is I would like to showcase you my website where you can go and then where you can then see. So this is my website, means this is the home page of my website right here, right? So if you go on to the courses, here we have the WireShark. Consider this package 1 here because there's a discount right now on this WireShark from scratch. So if you it's a 1599 rupees course, means 1600 rupees course. It's a 50% off. If you just click on buy now, you are going to get this 800 rupees discount. The other thing, as I was mentioning that if you go into this digital products, right? In this digital product, you will find this WireShark files for all networking protocols. You will see here, and you can download it. So all these WireShark files are going to be with you. It doesn't matter whether you join this course or not. Believe me, if you just download these files, if you have the understanding of packet structure, which I explained in this in today's class only, you should be good, right? And just do some hard work on the wireless, just understand the filter. You do not need to join this course, but if you do, then you can give that complexity portion to me and I will take care of that. Having said that, this is what I have in my mind for today's class. See you next week. So basically there are going to be 5 classes over the period of 2 weeks, means 3 classes next week and 2 classes next to next weeks, right? On the weekdays. And if you register them today using you must be getting a link in your WhatsApp message, and you can, or maybe you can just come here and go here and register for this course. By the way, my website has so many other courses. Every course is taught by me in very, very simple language. And there are separate plans also, 3 months, 1 year, and lifetime. If I were you, I would have chosen a 1 year because it is going to give me the flexibility. It is going to give you all my course, which I'm going to teach in future also, and the current courses. And 3 months plan is having so many courses also, right? This is the table which is going to explain you. So this is what I have in my mind for this session, right? Hope you have enjoyed the session, and now the time for your question answer, which I'm not going to record anyhow. Thank you so much once again for coming up on waking up early on Saturday morning and attend this class. Thank you so much for registering in the huge number also. Bye for now. See you in the live class or the first class of this course. Bye.